Hello everybody. This is a video to kind of answer a question that I got in the comments on the last video, and the question was wanting to know about hooking the meter up and where you measure voltage, what you do you use DC, AC, when do you use each one, where you connect to, and everything. So I've got a couple examples of radios. One here is a transformerless AC/DC radio. It's a 6-tube radio, so it's not really, it's designed like an All-American 5, except it's got an RF, tuned RF front end. And then I've got a Philco 3760, I believe it is, that would be a representation of a transformer radio. So I thought we'd kind of go over some of this. First, a few things about safety. This radio, being it has no transformer in it, I've got it right now connected into a variac, which is then in turn connected to an isolation transformer. Now, the one thing I want to say about some safety things, first and foremost, every bench of everybody who's watching me, if you're ever going to be working on radios, on your bench, the most important tool that you ever will have on it is an isolation transformer. It's the only way you can truly be, or a lot more safer. Because a lot of radios, especially really getting in the late 40s and into the 50s and 60s, may not have transformers, and the chassis could be hot. This one here, actually, the chassis is floating, but it's only floating because of a capacitor. If that capacitor, it's a paper cap, so if it goes leaky, then the chassis will suddenly actually become hot. But some of them, the chassis are hot. They're connected to one side of the line. So for pure safety's sake, always use an isolation transformer with any radio that has no transformer, or any TV that has no power transformer. And really, there's no harm in actually hooking your transformered equipment to an isolation transformer either. It's not going to hurt anything, just to be just a double safety, just in case there is some strange thing going on the primary side that might have some leakage there. Now, that being said, we're connected through an isolation transformer and through a variac. The radio has never been touched. It does have one replacement cap here that was put in there before I ever got the radio. This is the line. This is not really a the proper line filter cap. This is a film cap, and then it's really just tacked in. So that will be eventually replaced, but the rest of the caps are actually the original caps. The one thing I wanted to show on this more than anything is a lot of these will have these type filter caps where they're just a tube, cardboard tube, and wires coming out of it. When you're doing your DC voltage checks, your schematic most likely will have voltages on them. This says 95 volts here on the plate, 95 on the screen grid. Sam's also gives you a resistance chart here. Sometimes they'll put another one here, which will be just like this table here, and it'll be the voltages. In this case, they decided just to put the voltages right at the tubes. Now, these voltages are referenced to circuit ground. since the chassis floats, and the way I know the chassis floats is simply by looking at the schematic. It has a reference here where it shows 2 grounds and a cap. Well, C13 is this cap right here. There's a wire right here that goes down underneath and is affixed right here to the chassis, comes up, hooks right to this little center point on the tube socket, and then from there the cap's hooked to it and then comes over here. This is the DC negative. This will be the ground for the circuit. I want to point out how you can actually find ground, because sometimes these are not really easily to find ground. Now there's several different ways. One, you can go by the cap, and I'm going to see if I can zoom in on that cap. It's kind of hard to read, but we'll try to zoom in a little bit here and see if we can get a read on it. Now it states red 100 microfarad, 150 working volts. Yellow 50 microfarads, and it's scraped off here, but that's probably 150 working volts. And then it says black is negative or common. Well, that tells me that's the negative side. The negative side of the capacitors. And if we actually look at them on the schematic, which we'll have to bring down here. I'll find myself on here. Here we are. The negative sides are connected to ground, circuit ground. So that's that black lead. The black lead's right here, coming out. It goes where I've got this wire connected, alligator clip, right to here, and that gives me my negative. Now, when you're doing measurements, what you want to do is affix, and let me zoom back out here. Oop, wrong way. You want to fix your negative lead from your meter so you don't have to keep messing with it. The negative lead's going to go to ground, and it's most all your measurements is going to be measured, taken to ground, measured across to ground. So this can be affixed and then left alone. So if you don't have something like this to go on, you can use a test lead like this, and that's another nice little tool you should have, is some test leads. They're not expensive, they come in handy, but you can fasten it on there and then fasten to your negative, which is this black wire here. Another point, if you can't find this, or for some reason not sure where it's at, most of these radios, one of the tubes or a couple of the tubes, the cathodes will go to circuit ground. In this case here, the 12BA6 RF amp, the cathode goes directly to ground. It's easy to locate the tube. It's pin 7, so it's easy to locate that you could connect to. Now, these are DC voltages. Your plate voltages, your screen grid voltages. It may have a cathode voltage. Here it does, since there's a cathode resistor. Sometimes they may have grid voltages, like right in here and on the IF tube. Sometimes they don't. But all those voltages are DC voltage. So you set the meter to measure for DC. And then, for safety reasons, you use one hand with one probe. Since the negative of your meter is permanently affixed for the time being, you can use one probe, and then you can measure your various voltages. Now, this schematic happens to be really nice, and it shows pin 1, pin 2, pin 5, pin 6, 3 and 4 on the heater, pin 7 for the cathode. So it's labeled the pin numbers. If they're not on your schematic, you can look them up on you know, in a tube manual. You can get tube manuals free for download. There's several sites. I've done videos on that before and given sites. You can either look that up, other people's done them, but you can also Nostalgia Era for one place .org. You can go there, and they've got not only do they have schematics, but they also have where you can go to tubes, and you can click in what tube you got, and it'll give you the tube layout, pin out, and you can then mark on your schematic your tube pins. There's also other sites that you can get full downloads of tube manuals, and you just Google it, and you can find those sites and download you some tube manuals. Now, all you got to do, most of your voltages that you ever measure in the radio will be around the tube. That's your primary voltages you're looking for. Pin 7 here shows 120 volts coming out of the rectifier and feeding, so that'd be right at this capacitor here, which is part of this filter, which is actually right here. The only other voltages that'll be on the tubes will be AC voltages, and they're the heaters. And it lists roughly what they are: 48 volts AC, or 85 volts AC, 48 volts AC, 35 volts AC, 25 and 12. It tells you what tubes they are, and you can actually measure those if you want. If the tubes are lighting up, they're probably fine. But you could take measurements of these, but these will be, all your heaters will always be AC voltage unless otherwise told on the schematic. Now there's some TVs especially that will rectify sometimes certain heater voltages to give a pure, or as pure DC voltage as they can to the heaters, and some tube test equipment does that too. But on radios it'll always be AC, so you always check with AC here, the heaters, whether it's in a series connected set like this, where the tubes are all connected in series, or a transformer set, and then you're going to have, generally it'll be probably 6.3 volts and 5 volts for if it's got a 5 volt rectifier. Now let's see, so the other things to discuss here is about the meter itself, and I want to come down to this and let's look at the meter a little bit. This one here is an auto ranging, and especially for newbies who are not really very experienced with measuring voltages and working with these tube sets and various things, I really recommend, if you haven't bought a meter yet, an auto ranging meter. It's number one, safer for the meter, and then consequently your pocketbook. Now a lot of meters like this one are protected with fuses, but that doesn't always mean you can't damage the meter. If it's not auto ranging, and if you got and you're checking voltages, the range too low, on too low of a range, you could get in trouble where it could damage your meter. If you do have a meter that has ranges on it, then always, when in doubt, or even not in doubt, set it to the highest range on voltage and then work your way down. Each time you click through and change a range, pull your lead back away so you're not reading anything across it, and then switch down and go back and check again, see if you get a reading. And until you get a decent reading on it, you can keep going down. If you're checking resistance, you kind of actually do it in reverse of that. It's best to start low and work your way up in ranges. And that brings up the other point why in auto ranging, when you're not real experienced, you could have, like checking resistance, say of a coil or transformer winding or something of that nature, have this thing set, you know, where it's either like too high, where it might show and call it a short and you think the winding is shorted, or too low and it goes out of limits, it calls it open, or out of limits, OL, and you might think, well, I got an open coil or open transformer winding. So when in doubt, change the setting range when you're checking resistance, and to see if you can ever get a reading. You know, if it's saying it's shorted, keep turning it down and scale until you get a reading. If you never get a reading and it is truly shorted, then it is. If it's saying it's out of limits, or it can't read it, or it's open, then start going the other way. One other thing about meters, and kind of a pet peeve of mine, is these meters have what is known as a continuity. And hold on, I'm back. Sometimes you have to answer a phone. Now back to my pet peeve, a continuity test. And basically what that does is when you turn it on, it says open. If you bring the leads together, it makes a sound and it says short. And the batteries are getting a little weak in this. I need to replace them. It's not as loud as it used to be. Don't use continuity tests to test coils, transformers, or any other type of windings. Some meters may go ahead and give an actual reading of resistance, but it'll be off. Otherwise, it's going to either beep at you if it's within the range of the continuity. A lot of these meters run 50 ohms and less. Some even just 20 ohms and less will only show continuity. Some it's 50 and less, it'll show continuity. So a lot of your like IF transformers will, you know, show it's continuity in it. In other words, the coil's not open, the winding in that transformer, but it doesn't tell you if it's shorted. So these will have, most of the time will have some sort of resistance on them. Now on this set, it doesn't tell you the resistance that I can see right off the bat on those coils, although it may be in the parts listing. A lot of times it is. Yeah, and it is. So the IF, both IF transformers, it's got the primary and secondary resistances, which happen to be 14 and 13 ohms respectively. But they will, you know, a lot of schematics or in their parts listing or something will give these resistances, resistance for the primaries and secondaries of the audio transformer, and if you know, the other coils that's in the set, it'll tell you that. So use resistance on those. Check them and see if they match up to the resistance that's shown in the schematic, not continuity. Continuity, great for checking switches. That's what it's really designed for. Check switches, check for broken wires, bad traces on circuit boards, things of that nature. You may have a wiring loom that is disconnected at one end. Maybe it goes to a speaker and you've disconnected, or it was disconnected, and a lot of times them old wires that's in there, it's in a loom. It may be in a completely jacketed loom, so it's very hard to trace. It may have color codes, but a lot of times those color codes are really faint, and lost all their colors, so one wire looks the same as the other one. One thing you can do is put your meter on continuity, connect to one end, look at your schematic and see where the different connections are, and start checking in the radio where those connections are, and you can find each one of those wires and be able to label them and know what they connect to. You can also check wires that's in a loom that maybe you suspect is broken, or it's got a break in the wire. You can check switches to make sure that they're operating right. Like your power switch, you connect onto it, you turn it on, it should beep. You should hear the beep from the meter, and if you don't, then the switch has got a problem. So those are the things you check. Check any switches you want, rotary switches, power switches, any type of switch, and checking wiring, either tracing it or checking for broken wires or something that, especially in looms where you can't really trace it out and check it. The nice thing about the continuity tester is the fact that it makes a noise, so when there is continuity, the wire's good, or you found the other end, you found the correct end, you get a beep. You don't have to look at the meter. I mean, you could do this with resistance, but you have to watch the meter. But everything else, coils, transformer windings, IF transformers, power transformers, anything, those things use resistance measurement. Check the ohmage. Okay, now let's see if I've ran this radio a few times before we got here, so it's cooled down. We'll let it warm up a little bit. I ran it mainly because I wanted to check the capacitor filter cap, and it's not getting warm. So, and the radio does work, although I will restore it. And it takes a little time to come on.
Well, Dave, we started off with our take-home pay. We're both high school teachers, so our pay is a little bit different, but our take-home pay was right at $3,000
so,
and just over $80,000 now.
It works pretty good. Excuse me. Now, according to the schematic, we're just going to take a couple readings here to show. According to our schematic here, the RF tube, RF amp, the plate, which is pin 5, should have 95 volts, and the screen should be 95 volts. So we can check those two voltages right real quick. They're easy enough to find, and kind of rotate this just a little bit. You can count them off at pin 1, 2, 3, 4, and 5. So if you can see the meter right there, we get 95 or 94.2 volts, close enough to 95. And pin 6, which is the next pin over, is right on 95, 95.1, 95.0. So it's flipping back and forth between the two. Is the screen. Now we do have a couple other voltages on there. Looks like pin 1, which is our grid, should be somewhere around -1 volt, either -1. So here's pin 1. Let's see what we got. And our grid's reading just a tad bit high at -2 volts, but that could very well be that because I've got a signal going on. And there we go. We get off signal, we're at coming down. Now,
well, you've got to decide. You want a house or you want to go to college?
Back on the signal, the voltage goes up, or goes more negative.
You have to learn the word no.
And what that's showing, what is going on there, is the AVC kicking in. And suppressor grid is actually connected in and should have a feed on of about 0.2 volts. I don't know if you can actually see that. Goes up the suppressor grid 0.2 volts, and that happens to be pin 2. Let's see if we can get a read on that. Pretty close. 158, 160 millivolts. 0.2 be 200 millivolts. 170. So it's going up a little bit. So we're close enough. Off of pin 7 is 120 volts on the 35W4. So let's see if we got that. If we come in here, we're a little low. Which we're showing 112 volts. So we'll go to pin 5, but pin 5 tells us 112 volts AC. So we want to switch there. So pin 5, 1, 2, 3, 4, 5. Let's see if we can get a... It's 110. And that may be because I'm running just a teeny bit down, or 2 volts low. I could probably crank it up a little bit on the variac. That kind of gives you some idea what you're looking at about measuring voltages and how to do it, how to find ground. Ground is the negative lead here. Or if you look up a tube that has where we go directly to ground from the cathode, you can find the cathode pin on any tubes that does that. Now we'll shut that radio off and we'll look at a couple other little things here. Got a little different radio, and I need to rotate around. Okay. Now this one is not ready to be powered up, so basically I'm just going to show you some stuff here. Transformer, it has a transformer in it, and most transformer radios will have the chassis as ground, so all you got to do is pick a good chassis point to get ground from, and I would probably pick this ground point here. Again, hooking it directly with a gator clip, and that way I don't have to mess with that lead anymore. And then all I got to do is I can look on the schematic, find my different voltages to my different pins, count off which pin it is, and measure the voltage at any one of the tubes. Now a radio like this, most of the tubes are fairly open except this guy here. Now in a case like this one here, it's kind of hard to get down into to measure any voltages off of it. On something like that, one thing you can do is use another, shut the radio off and use another gator clip like this, and you can reach down in there once you know which pin you want and clip on there, and then clip it on to your meter, then turn the radio back on, let her warm up, and check your voltage. And if they're real hard to get down into, you can always use a pair of needle nose pliers and just clip on. That way you could get down in there. Now another route you can take is use, this is for a 7-pin, but you can use, if you got one of these or make one, it plugs in where the tube goes in. You plug the tube in here, and then these are numbered off, and you can clip onto it from the opposite side so that you don't have to deal with being in a tight area. If this, now I'll explain what this is, but whatever's in your way, if you can actually maybe rotate it, because this has got a screw, the possibility of rotating it could be there where you can get to it too. In this case, I won't rotate. What this thing is here, this is a voltage divider resistor. There's 3 resistors in here. It goes from ground at one end of it. They're all connected together. One end goes to ground, the other end goes to the center tap of the high voltage secondary. And what it's used for, this allows different points on here, allows to develop negative voltage for biasing, such as bias for the output tube, the no signal non-AVC voltage bias for all the other tubes, such as the front end tubes, such as the I believe it's the 6A8 mixer tube, and the 6K7, which is the IF tube, is also developed off of here. Now when it does get a signal, an AVC voltage is produced, it goes above or more negative than this, but it sets the baseline. And then I think the other one goes to, let's see, I have to look schematic and tell for sure. It's been a while. Yeah, the other one goes and supplies bias voltage for the first audio, the triode tube in the 6K or 6Q7. And that's what they got this in here. So, but the main ground, circuit ground, is chassis. That's one of the main things I wanted to point out. Now, some other safety issues. When I'm actually working and checking voltages, I use my right hand. This probe set came with these little ends that you can put on here. They screw on so you don't have all this metal. If you don't have something like that, or a probe set, or you know, something to put on the end of your probe, and you're worried about, you know, if you get in here and what if you get across something, you know, you can put like heat shrink tubing or something on there just so you have just the tip showing out, whichever way. But you use one hand and you don't do this to check. You know, make sure you can stabilize your radio somehow. You know, put something underneath it. The best route is with it fully upside down. If it'll rest there without touching anything, this is actually touching the cans, the filter cans, so it's pretty stable. But you can also put things like, you know, some old wire deals or coffee cans or whatever to hold it up and hold it stable. The one thing you don't want to do is have the chassis sitting there and it's a little unstable, like on its side, and it wants to rock over and you grab a hold of it and then you're still measuring. Do not do that. This gives a path across your heart. You don't want a path across your heart because that's how you get killed. So one hand only, no jewelry on that hand, so you don't get burnt, cause a short that can harm you, or anything else. Now the other thing about measurements of meters, now again in this everything is DC except for the heaters, and those are AC. In this case, all the tubes except for the rectifier tube, which is actually mounted on top of the transformer, that's why you don't see it. All the other tubes are 6.3 volt, and they'll be, most of them I think are pin 2 and 8, or pin 2 and 7. The rectifier tube is a 5Y3, I believe. 5Y4. And it has a 5 volt. It'll be, but all of them are AC. So in those cases you use AC. All other voltages, always DC. The only other things you might do with a meter is check current. Now, how do you check current with a meter? It's got current on it. Well, for one thing, you'll be setting it to either microamps. And in the case of this meter, now some meters, especially meters that's got ranges on them, they'll have AC and DC amperage readings. So you want to set it appropriately that way. If you're measuring DC voltage, it'll be DC amperage. If you're measuring something like the heaters, where you have AC there, then it'll be AC amperage. But this auto ranging, it'll detect whichever it is and go there. Make sure you're on the right scale. If you're measuring, like here, milliamps, this will be for milliamps, and it'll auto range up to 400 milliamps. This is the microamp range, so, and I'm not sure exactly what its max is. It doesn't say. It's probably in the manual. So, you know, you set it to whichever one you want there, up to 400 milliamps on the milliamp range. And how you check amperage is you have to literally put the meter in the circuit. So wherever you're checking the amperage out, whether you want to check current coming into a cathode, the cathode of a tube has all the current that's going to go through the tube comes through that cathode. So you would have to break the cathode loose. In other words, you have to unhook the wire from it. If it goes to ground, disconnect it from there. Hook one lead, if it's grounded cathode, one lead to ground and the other lead to the cathode to measure current. But current, the meter actually goes in the circuit. Just like a, you know, whatever's there, you know, like a resistor being in circuit. But the meter goes in the circuit. And then you set the appropriate range. In this case, this will go up to 400 milliamps, but if it was going to be higher, I switched the leads, and we have a 10 amp range here, which is fused, and I can go up to 10 amps then. But that's how you check current. Current is done in circuit, so you have to break the circuit and put the meter in the circuit. And wherever you break it at, that's where you hook it in. You know, if you're disconnecting a lead, say from a pin on a tube, like maybe plate current, you disconnect it from there, then you'd hook the meter to one side and then the wire to the other end. Don't worry about with these meters about whether you got the meter hooked in right or not. It's DC there, so don't worry about the, what will happen is if you got the meter hooked in backwards, you'll just get a minus. Same with voltage. If you got the meter hooked in backwards, you'll just get a minus voltage where you think you should have a positive, like plate voltage. The same with current. If you get it hooked in backwards, you get a minus current, but it'll still read the proper current. So don't get too concerned about that point. Let's see, anything else on this? Not particularly. When in doubt about current, one thing you can do, if you're not sure what range to be on, maybe the, I don't know, schematic may not have current. A lot of them don't. You can find rough ideas from it from a tube manual telling you how much current may be typical on a, like the plate current, screen current, things of that nature. But if you're not absolutely sure but you still want to test for it, what you can do is use something like a 10 ohm resistor and put in circuit. In other words, where you would normally put the meter in the circuit as a current meter, instead put a 10 ohm resistor there and get you one of them 1% 10 ohm resistors. You can even go ahead and measure it prior to putting in and write down that exact measurement, but put it in and then you can measure the voltage drop across that resistor, and then do Ohm's law. Voltage divided by resistance gives you current, and that way it gives you a safe way of checking current, not having to worry about how you hook the meter up, or if it's on the right range, or possibly damaging the meter. Trying to think if there's anything else. That's really the main nutshell in it. Familiarity with the schematic will help you a lot, both with your voltages and having a tube manual to get the pin numbers for the tubes, and things of this nature will help you and know where to connect up. But basically all your DC voltages, unless otherwise stated, will be referenced off of ground. So in other words, your negative lead, common lead off your meter will connect to ground, and the only thing you'll have to do with is locate that ground. Transformer sets generally will be chassis, so the actual metal chassis, so just pick a good spot that you can get a good connection. Use a gator clip, test lead, that way you don't have to keep it held there, and you keep both hands away from the chassis. Use only one hand for measuring. Follow your schematic and the voltages on there. They don't have to be dead on. A lot of these have different measurements. They use different equipment for measuring. The equipment you're using, like these digital meters, don't load the circuit much. They're 10 meg input impedance, so that means they're just like a 10 meg resistor. Whereas some of these schematics, some of these old radios, this one here, actually the schematic states that they used a 1000 ohm per volt meter, and I've discussed what that meant before, but in a nutshell, when you set the meter on its range, whatever range you set it on, you take that number of volts times the 1000 ohms per volt, and that gives you the total input resistance to the meter. So in a case like say maybe plate voltage on here on 1000 ohm per volt, probably be on like a 500 volt scale, so you take 1000 ohms times 500 volts, and that'd give you the total impedance. But if you're measuring like maybe say the 6.3 volt AC line, to the heaters, then you're only looking at it's probably a 10 volt scale, so 10 volts times 1000 ohms per volt, that's 10,000 ohms. So it really will load quite a bit versus 10 megs here with one of these. So it can change the readings, and a lot of times on these readings they'll tell you give this one here, nominal tolerance on component values makes possible variation of plus or minus 15% of these voltages on this other radio where I got this schematic for. So these voltages could be plus or minus 15%, and they're using they're using a vacuum tube voltmeter, so that's 11 megs, so that's real close to this. They're also telling that they'll be running 117 volts on the line coming into the radio. That's where a variac kind of comes in handy. In radios that don't have a transformer, it's not real big a deal. You might have 120, 125. It'll only inch it up a little bit. But radios with transformers, it can be 30, 40, 50 volts more coming out on the B plus line. Difference between your regular outlet and what the radio was looking for and what the voltage is from. So if you're within plus or minus 20 volts on any of these voltages, that's basically the nutshell, you're probably going to be okay and stuff. So I can't think of anything else to really say. If there's any questions, I'll do a follow-up to this. If there's other stuff you'd like to see in test equipment and hooking it up and stuff, or possibly me try to talk about maybe one particular radio, if I can find a schematic or something, or if I have one, I can kind of go over that. So until then, though, thanks for your comments, and thanks for my new subscribers and stuff. And I suppose this has ran long enough. My battery's about dead. So I'll see you guys on the next video. Thanks for watching.